different classes. The first is the interaction type. Fingerprint sensors come in two basic flavors when you talk about interaction. They're either of the swipe type or they're of the touch type. The swipe fingerprint sensors are the more common ones that you see on laptops, and the touch type of fingerprint sensors is the kind that you'll see when you come into the country at the U.S. visit program, or if you're members at PEFQ, when you interact with the fingerprint sensor on the ATM. That's a touch type of sensor. Then you have the acquisition technology type, like I talked about, optical, thermal, capacitive. These all introduce their own distortions and variations in the resulting sample. And then you have the sensor characteristics. What is the physical design of the sensor? What is the resolution of the resulting image? What kind of capture area does that particular fingerprint sensor have? These are all characteristics that will affect a person's ability to interact with the fingerprint sensor. What you see here are just sample images of the same fingerprint of the same finger that were taken across 9 different sensors that I used for my study. And if you were just to look at it even briefly, you'll see that you can see distortions and variations and in the resulting image just based on the type of sensor. And because of these distortions and variations, it causes issues when you try and compare these fingerprints. So this is just to give you some visual representation of it. So why is this problem significant to study? In terms of biometric systems, most of them have been monolithic in nature until now. But as distributed architectures become more pervasive, you'll have system use that can occur in different physical locations. Example is the ATM network. If you want to take, for example, PEFQ. PEFQ has ATMs all across campus. Now, for a user to be able to use the fingerprint sensor on a particular ATM, he or she should expect similar results when they use a fingerprint sensor on a different ATM. Well, this brings to light the issue of interoperability. What happens when you talk about a bank like Chase, which is across the nation? You cannot expect them to install the same fingerprint sensor across all the ATMs across the nation. So this problem will grow in significance as biometrics become more pervasive, especially within a distributed architecture realm. Just some definition of terms that I'll be using quite often throughout the presentation. The first is interoperable data sets, and these are defined by data sets that are created by collecting fingerprints on 2 different types of sensors. So when I talked about the processes with a biometric system, you can have enrollment or you can have recognition. So when the enrollment and recognition of the same individual happens on different fingerprint sensors, the resulting images basically comprise what is called an interoperable data set. And a native data set is one where the enrollment and the test images are collected from the very same sensor. And the false non-match rate, which was the primary metric that I used for measuring performance for my study, is defined as the proportion of genuine comparisons which are incorrectly rejected as imposter comparisons. So this is when a user cannot actually access the system as a genuine or the authorized individual. So the purpose of the study was to create a statistical analysis framework to examine the effect of these sensor-dependent distortions and variations on the false non-match rate of interoperable data sets. There are numerous metrics that can be used to measure performance of a biometric system. I chose to look at the false non-match rate, which is similar to a verification process. So you have another metric called the false match rate, which is the ability of the system to discern imposters from genuine people. And the second purpose was to analyze the impact of minutia count and image quality and skin characteristics on the performance of these interoperable data sets. Like I discussed at the beginning, image quality has an impact on performance. So these different fingerprints that are collected from different sensors might not be similar in image quality. So what kind of an effect does this have on the final performance of the data set? This is just the purpose of the study in a graphical format. There were fingerprints that were collected across 9 different sensors, and then the data sets were divided into enroll and test data sets. When the fingerprints were collected, the sensor characteristics were noted. Once a feature extraction happened, the fingerprint features were measured, and the final step was the matching operation. This is where the native dataset error rate and the interoperable dataset error rate were compared. And the idea was to look at sensor characteristics, fingerprint features, and the false non-match rate from a holistic perspective. So, like I mentioned before, there were 9 different fingerprint sensors that were used in this research, and all the fingerprint sensors provided images that were 500 dpi resolution. This was a decision that was made to create a baseline for all the fingerprint images. There were four sensors that were of optical touch type. There is only one commercially available thermal swipe sensor, so that was used for the study. There were 2 fingerprint sensors that were of the capacitive swipe type, and all laptops that come equipped with fingerprint sensors, the technology that they use are capacitive swipe. So and there were 2 other sensors that were of capacitive touch type. So the idea was to try and have sensors that would fall into the 3 different types of categories for the variations and distortions: the interaction type, the technology type, and the different designs. And the criteria for choosing these sensors was that they all had to be commercially available. One of the underlying themes of this study was to make the results pertinent to industry, and to basic science, so that they can actually devise systems that can be used better in the field. This is just a snapshot of all the different softwares that were used to collect the fingerprint images. Unfortunately, a single software could not be used to collect all the fingerprint images, so I had to use five different ones. And when I talked about fingerprint characteristics, I collected temperature, moisture content, oiliness, and elasticity of the finger skin before a user interacted with the fingerprint sensor. And these were the 2 devices that were used to collect those measurements. On the left, the device that you see collected the moisture, oiliness, and elasticity, and on the right you see a device that captured the temperature on the finger skin. Just a few of the important assumptions, limitations, and delimitations of the study. The assumptions were that all participants were treated as cooperative users, so they were not maliciously trying to provide fingerprint images of bad quality or trying to interact with the device in a wrong way intentionally. And the integrity of the commercially available products was considered to be consistent with their product specifications. So that was the baseline. The delimitations of the study was data collection was performed in a single visit. So there was no time gap between enrollment and verification attempts. And the environment conditions were controlled, since one of the scenarios that this study was trying to simulate is kind of an office environment where you as a user would get to interact with the device when you try and log onto your computer or log onto some kind of a network resource. And all users were allowed to do a practice session. And the idea behind the practice session was so that people who have not interacted with fingerprint devices before have an idea of how to interact with the device. And one of the limitations was kind of goes off